Hi, quick video on evaluating composite functions using the sketch method, where we're going to have to draw a picture and relate things in either x or y values and maybe use some identities along the way. So let's take a quick review of some of the identities that we are familiar with. All right, so we have your basic trig functions. We've got sine of theta is equal to opposite over hypotenuse. That's the SO in the SO, ka, toa, right, if you recall that. We have cosine is equal to adjacent over hypotenuse. Tangent is opposite over adjacent, the toa, opposite over adjacent. Cosecant is 1 over sine, a reciprocal function, a reciprocal trig identity, which means that we have the hypotenuse over the opposite. Secant is 1 over cosine, or hypotenuse over adjacent. And then cotangent is 1 over tangent, or adjacent over the opposite. So a couple things that we're going to need here are the trig, some identities, and Pythagorean theorem. So here's your Pythagorean identities. Pythagorean theorem we know is a squared plus b squared equals c squared. And the Pythagorean identity is sine squared of theta plus cosine squared of theta equals 1. Now just go back to a little geometry practice here. We always look at the angle A are capitalized, so angles are capitalized, and the side lengths are small, lowercase letters. So angle A, opposite of the length of A. B, angle B, opposite length of little b. And C, the hypotenuse in this case, is the length of C from capital C. So capital letters, again, are the angles, and lowercase letters are used for notation in the length sizes. So, all right. And it won't always be A, B, C in that structure. Just look at the context of the problem, and that will help you out. All right, so here we go. Example number 1. It says, evaluate the composite trig expression using the sketch method. So it says, here's cotangent. The sine inverse is negative 1 over 3. So what we want to do first is draw the triangle in the proper quadrant. So I've got the quadrants laid out here, quadrant 1, 2, 3, and 4. Now how do I know to draw it in quadrant 4? Well, remember, sine inverse only operates between pi over 2 and negative pi over 2. And if the sine is negative, well, remember, all students take calculus, which means that everyone's positive up here. And if I'm only looking between here and here, negative pi over 2, then it must be in quadrant 4, where the opposite is negative and the hypotenuse 3 is positive. Remember, hypotenuses cannot ever be negative. So, your restrictions again. Sine inverse of x equals y, negative pi over 2 to pi over 2. So, number 2. Let's see. So, or step 2, I should say. What do we do next? The inner portion is represented by the sketch. So all this inner portion is already represented in this sketch. So I didn't have to do anything. So do we really have to find theta? We really don't, actually, because it's not asking for us to figure out what the angle is. The angle is represented here by this information, so that's pretty cool. And there's not really, there's enough information to get the angle if you wanted to, but remember, it's just asking for the cotangent of that information. So, cotangent of theta is equal to the adjacent over the opposite. So in this case, our x value is the adjacent to the angle. So the x over the opposite, which is negative 1. So how do we find x? Well, we can use the Pythagorean theorem. So x squared plus negative 1 squared is equal to 3 squared. And as we work down, x squared is equal to 3 squared minus 1 squared. So we just bring this over. X is equal to plus or minus 9 minus 1. X is equal to plus or minus 8. And if we want to simplify that radical, we get x is equal to plus or minus 2 root 2. Now, so we have to ask ourselves, what will x be? Will x be positive or negative? Well, the cotangent, again, is opposite over, or the adjacent over the opposite. So in this case, we will get the adjacent side, which is 2, square root of 2 over negative 1, and that means we'll get negative 2 root 2 as our answer. All right? Okay, example number 2. Let's see, we have, switching back over here. All right, example number 2, it says evaluate the expression using the sketch method. But it gives us some other criteria here. It says that, and move it over a tad, here we go, there we go. All right, it tells us that if y is between 0 and 1, so it's greater than 0, but less than 1, or equal to, I should say equal to, write the cosine of the sine inverse of y. All right, the cosine of the sine inverse of y as an algebraic expression of y. So we've got some pieces here that we've got to fill. We have no numbers here. We're just a very abstract problem, but that's okay. We can work through it. First, we're going to draw a sketch. So create your right triangle. You can label it x, because x in the x-axis, y in the y-axis. Now you might ask yourself, well, how did you get 1 here as the hypotenuse? Well, most of these problems will be dealing with the unit circle, and what do we know the unit circle is? Go ahead and pause the video and think about that. What is the hypotenuse of the unit circle? It's right. It's the radius. You're correct. The radius of the unit circle is 1. So, how do we know that? It's the radius of unit circle. So, we can put radius of unit circle. Radius of unit circle. Incidentally, if we know that y is less than or greater to equal to 1, that means this y value here has to be less than or equal to 1. So it could be either all the way over and up, again the radius, or it has to be less than, so we know it must be in that realm. Okay, the next thing is step 3. Since the sine of theta is equal to y over 1 now, then the inverse sine of y over 1 is equal to the angle. All right? Now we can use all that information put together. Use the Pythagorean theorem to write all in terms of y. So let's see. We normally have x squared plus y squared is equal to 1 squared. X squared plus y squared is 1 squared. And now we can solve it for x. So we get x squared is 1 squared minus y squared. And then we get x is equal to plus or minus the square root of 1 squared minus y squared. So here we have a representation of what x is, and that's what they wanted. They wanted everything in terms of y as an algebraic expression of y. The cosine. Well, remember, the cosine is the adjacent. The cosine is the adjacent over the hypotenuse. So all along, what we want to do is we want to get rid of this x and put everything in terms of a y. So now we know what x is. We have it right here. So we can simply wipe away that x. All right, we get rid of that x and put what? It's the square root of 1 minus y squared. Square root of 1 minus y squared because of the Pythagorean theorem. So the cosine of the sine inverse of y is the square root of 1 minus y squared all over, that's right, the hypotenuse of 1. So there we go. We have done it. We have written it as an algebraic expression of y. All right, there you go. Go back, rewind that, check that out. Here, I'll move out of the way so you can see the rest of it. And there's your information. Hope you have a great time. Great night. Talk to you soon.